Example 3 read, a rectangle has one corner on the graph of y equals 25 minus x squared, another corner at the origin, the third corner on the positive y-axis, and the fourth on the positive x-axis. So what makes sense most to me, let's sketch this out. Okay, so you have a rectangle. One corner on the graph of 25 minus x squared. That's an upside down parabola. So if you want to write it this way, this is how you do it. That means you go up 25, because that's where the y-intercept is. So here's 25, make a graph. Your x-intercept would be 5, because x-intercept is when y equals to 0. So if I go 5 this way, negative 5. So this is your sketch of a parabola, okay? Then it said you have a rectangle. One, it's on this curve. Well, what did I do? There you go. One, that's one vertex. Another one at the origin. The third on the positive y-axis, because the rectangle, this has to line up where you plot the first dot. And the last one on the positive x. And again, same thing, because the rectangle, this has to line up. So this rectangle, you can make however size you want. I mean, technically, I can make this size, right? Technically, I can make different color. Here we go. Technically, I can make like skinny this way. So it's really a personal choice. But right now, let's make that blue one, since I already make that the prettiest. Okay. So there's a blue one. We drew that out. Part A, express the area, let's call it A, of the rectangle as a function of x. So x here, it's the base. So x is your base. We don't know how big that is because we just randomly graph that out. So that is x, and this is then y. So this point right here is x comma y, because we don't know how high it is, and we don't know how wide it is of the base. So area is, here we go, area, it's going to be length times width, which is really x times y, but it only wants in terms of function of the x. So area in terms of x is, well, x will stay. Well, what on earth is y? Well, congratulations. Y is this. Y is 25 minus x squared. So all I have to do is substitute y with 22 minus x squared. And from here, we can distribute. So area in terms of x is 25x minus x to the third, and we box that up. That is the area formula in terms of your x. Would I also accept non-distribution form? Of course I would. You can even box that up. Question B, what is the domain of A? And again, the domain is talking about what value can x be? In this case, it's talking about what values can the base of this rectangle be? Obviously, x is the base. The smallest base you can have is anything slightly bigger than 0, non-inclusive 0. Well, what's the largest value you can have? Well, the largest base I can make, it has to be no more than 5, so non-inclusive 5. Why 5? Well, the reason it has to be 5 because this parabola, it's outside of this rectangle, aka this rectangle is inscribed inside of this parabola. So it cannot go any further than the x-intercept. Graph your area formula. Okay, let's find decimals. So let's find decimals if it's still around. Let's see. All right, here we go. Here's my decimal, slowly coming up. X that out, and what I want to enter is x. Let's see. We want to enter 25, I'm sorry. Well, I guess I can technically do x to the third first, or negative x to the third first. Dude, come on, get it together, right? Okay. Negative x to the third, or 25x first. Well, 25x, let's do that first. Subtract x to the third. Perfect. Now let's zoom in the applicable portion of your graph. Not everything is applicable. Now, what do I mean by that? This is a graph. As you can see, it's a cubic, so it's going to look like a cubic, but it's an application. X represents the base, so you can't have anything negative on this graph. So you want to zoom in for the X, anything that's bigger than 0. Well, in addition to zooming that in, let me make this darker for you, okay? Projector mode, there you go. And I want to make sure the scaling, we don't want any negative here, so we'll start at 0. And we don't need that much because let's do 5. Okay, perfect. So this is pretty much all I'm going to focus on, this area. Well, that's the graph. Let's go and sketch that out. A parabola. Even though the entire function is a cubic, but the applicable part, and you only need to sketch the applicable piece when it comes to an application. So X represents the base, Y represents the area, and based on our little sketch, the max you can go is 5, and then like that, okay? For what value of X is the area the largest? So now you can use your calculator or decimals. If you are using your calculator, I will help you find the maximum in your calculator, on your graphing calculator. So let's find the large, oh, I didn't mean to pinch it in, I mean zoom it in. I just want to find the largest area. All right, there we go. So based on this, as you can see, it is 2.887, 48.113. We will take this back and we'll write that in our answer or notes. Now when you get a point from your calculator or your decimals, make sure you know what it stands for. So we saw a point of 2.887, 48.113. This is X, this is Y coordinate, but Y in our application is talking about the largest area. So how do we want to write this out? We want to write the largest area, even though it didn't ask for it, but most likely I will ask on the test. The largest area is 48.113. We did not get the unit of measurement before, so we just use square, unit square, when X is 2.887 units. And box that up, we'll highlight that over. Okay. And that's how you solve the largest area type of questions. Once you have the equation, you can use your graphing calculator. In the graphing calculator, you want to do zoom and zoom fit, and then do second calc, and then the maximum. Now, if you use decimals, that's also okay as well. Example 4. A manufacturer of children's playpens makes a square model that can be opened at one corner and attached at the right angles to a wall, the side of a house. If each side is 3 feet in length, the open configuration doubles available area in which the child can play from 9 square feet to 18 square feet. Now suppose that we place hinges at the outer corner and allow for a configuration like the one shown in the next figure, figure 2. So what's going to happen is we would like to kind of open this up, okay, and make it into this right here. Part A. Build a model that expresses the area of the configuration in figure 2 as a function of the distance x between the 2 parallel sides, okay? So in this figure, it tells you what x is, and it says here x is the distance between 2 sides that are parallel. So here is x. So this is what we need to know, okay? So build a model that expresses the area. So let's talk about the area. Would you agree the area of figure 2 consists of 2 things, the rectangle and that triangle piece, once you open up this third side right here, okay? Well, let's talk about the rectangle. Well, this is the rectangle. It's going to be length times width or base times height. Doesn't really matter of what you want to say. if I know the area of that rectangle plus the triangle, then I could figure out the area of the whole box. Let me draw the triangle this way. Okay, so what I'm really trying to draw is take this triangle, draw it over here. So it's not really upside down for you to see it. Okay. First, we know, as you can see, this base right here is x. And it gave you a height right there. And it highlighted for you. See this h right here? That's your height. So we'll just draw that right there, and this is a right triangle. I can find the area of a triangle. Okay? And we also know a couple of things. We have sides of 3s. So these are both 3. Now there are multiple ways of going about this. Okay? So one of the way is, if I know the base, the entire base is called x, I can just use half of this. This is half of your x. Okay? So with that in mind, then I can just say, okay, well, I need to find what the height is. Well, that's not too bad, because in a right triangle, which I'm really just using this piece, okay? And again, this is not the only way about solving this. I'm using the right triangle, because in a right triangle, I know it's a squared plus b squared equals c squared, since I need to know what h is, okay? H is unknown. So let's figure that out. This is just a triangle. A squared plus b squared equals c squared. I will use a squared as a half x, which is the base, a squared. Then my height, which is h squared, which is b squared, and then c is 3 squared. That gives me 1/4 x squared plus h squared equals 9. Okay. I would need to solve for h. Okay. I would need to solve for h. So h squared equals, I will move the 1/4 x squared over, 9, take away 1/4 x squared. We will now take a square root to both sides. Normally, I always tell you, remember, there's a plus or minus every time you take a square root, but because height is a distance, and the distance is always positive, so I technically don't need to worry about the negative. But I will try to find the common denominator. So this is now 9 minus x squared over 4. I want to find the common denominator so that way my numbers are a little bit friendlier. So I'm going to make the 9 over 1. So h equals square root 36 over 4 minus x squared over 4, which is really now square root of 36 minus x squared over square root of 4, since it's, well, if you don't see why I want it like that, then I'll do this. Over 4, which is now square root of 36 minus x squared all over square root of 4. So a nice simpler height would be square root of 36 minus x squared all over 2. So that's my height. Okay? And why do I need my height? Why do you think I need my height? Because I would need to find the area of the triangle. Okay. Now that we have the height, it's easy for me to find the area of a rectangle. Area of rectangle is going to be area equals length times width of the rectangle plus 1/2 times base times height. Well, length for this box, it's still, if this is 3, that's your height of the box, and then, or the width, and then this is your base. So if we know exactly what that is, we know this is x, okay, because this is x right here. So that is x. So we're going to go area equals x times 3, which is really 3x, equals 1/2. Your base is back to x, and your height, we just found it over here. So we are going to put it in here as square root of 36 minus x squared all over 2. Then let's make this pretty. Area in terms of x equals 3x. I'm going to multiply the constant out, so that's going to give you plus, change this to a plus for me. I was supposed to carry that down. Plus 1/4 x times square root of 36 minus x squared. Now, if you want to make that a little bit prettier, you can even write like this. area in terms of x equals 3x plus x times square root of 36 minus x squared all over 4. Either one is fine, okay? There you go. So that is the area in terms of x and only x. All right, now let's do the B piece and the C piece and the D piece, and I think we're done with this example. The B piece says, find the domain of A. Now, because your input is x, okay, domain is talking about what is the x can be. Well, let's think about this for a second. Would you agree the original box has this dimension right here of 6? So what's happening is it opens it up. Okay. So it opens it up to make this shape, to have a bigger plane area, just like in figure 2. So the most it can be is going to be 6. And obviously the least is going to be non-inclusive 0. Now why is it that it can be 6? Why is 6 inclusive? 6 is inclusive because if I have this x value being 6, then I'm just back to my original shape of a rectangle. Now if I move it, right, as I move it in, remember this is movable. These sides are movable, so you're kind of pushing it in so that way you can make to connect this. Because if you don't move this two sides in, this right here will not connect. There's no way that you can make the slanted, okay, of 3, because it's still just 3. So this is 3. If you don't move it inward, then this right here will not connect, and that's not going to make your figure 2 playpen. So that's why you have to move it in a little bit. So the most it can be is 6, and the least is 0. Part C says find the area when your x is 5. So what that's saying is, okay, well, move this in a little bit. Instead of having this a total of 6, let's move it in to have that 5. And all you got to do is plug in 5 for the area formula. So a of 5 equals 3 times 5 plus 1/4 times 5, and then square root of 36. 5 squared is 25. So I'm just going to write it straight in. So this is going to be 15 plus 5 over 4, square root 36 minus 25 is going to be square root of 11. So is that the prettiest we can do it without using the calculator? Did it give us unit of measurement? Feet. So feet square. If you don't have a calculator, I'll take that. If you have a calculator, you can enter that in, and that's about 19.15 feet square. Okay. Normally, I would ask for both. Then part D says, graph it out. So you can use your calculator, or let me power up my decimals really quickly and tell me what the largest area is. So let me find my decimals, okay? Decimals. Let's find you. Okay, so I'm graphing 3x plus 1/4, so 0.25x, 25, not 4. Then times square root, let's find where that button is. Square root, where are you? There you go. Times square root of 36 minus x, and then square. Okay, well, let's see what's giving me. What's going on? Ooh, look at that. Okay, so as you can see, first, if I didn't zoom it out, it looked like a line, because we are looking for the largest area. There has to be some sort of a curvature. So the largest area is going to be this guy up here. Let's see what that guy is. Okay. All right, so the largest area is about 19.817 at when x is 5.584. Okay, so based on the graphing, and yes, once you have your algebraic formula, then you can just enter that into decimals or calculator and then find the maximum. And the decimal that we just saw gave me this point, 5.584, comma 19 point, what was that? Let's check again. 19 point something. Let's verify really quickly. Oh, come on, computer. 19.817. 19.817. All right, say that to myself a couple times. 19.817. What does that mean? This is the input, this is x, and this is technically y. But our y is not really y. Our y is really the area, because that's our output right here. So make sure you know what y represents. So, for what value of x is the area the largest after you graph it out? So what I would like for you to do is sketch it out first. X represents your, I believe, your base. And then y is your area. I don't need an exact curve. I just need you to do that sketch. Then answer the middle half. For what value of x is the area the largest? What is the largest area? Okay. The largest area is 19.817 feet square when x is 5.584 feet. You can write both answers using one complete sentence.
So let's start with defining some vocab here. The first vocab is optimization. Okay, so oh, by the way, the title of this section is Build Quadratic Models from Verbal Descriptions. Okay, that means verbal descriptions can be word problems. Optimization is like to optimize. Okay, so make the best of whatever you got. Okay, so optimization is finding the maximum or minimum values in models. That means in the word problems. Okay, so for example, how could we find the maximum and minimum all in one? We don't find it all in one problem. For example, to optimize, for example, I have a cost problem, so I want to find the lowest cost. Okay, or I have the profit problem, so I want to find the max profit. So that's why this is minimum and maximum in different models. So the next one can you cross out the word demand and write in revenue equation? The next one I give you is the revenue equation, which is R equals X times P, where R is the revenue, okay. P is, hopefully, P is the price, which is pretty normal, and X is the number of units sold. Okay, and the law of demand states, okay, if you're in economics, the law of demand states that as P, price, increases, X, which is the number of units sold, decreases. Vice versa. Okay? Which makes sense, right? So if you increase, for example, you own a business selling t-shirts. If you increase the price, people are not going to think it's worth that much. But you know what I think? For this, the law of demand, it's normally true. But for some reason, Apple is immune to this law of demand. I feel like Apple, the price is ridiculous and people are still buying them. And they're sold out like crazy, you know, like a few hours after an iPhone's release. So I think the law of demand holds in most cases. You can prove me wrong. You can tell me, you know what, it worked for Apple as well. But when it comes to Apple products, I feel like it doesn't really apply to Apple products. Okay? All right, moving on to two more vocab here. All right, not really vocab. So if you look at this scatter plot, okay, this is not a linear relationship. This is a parabola, and it opens up. So we're going to have an equation, y equals ax squared plus bx plus C, and since it opens up, A's got to be positive, okay, which is greater than 0. This one, non-linear scatter plot, okay, so we're going to have a y equals 8x², same equation. The equation itself is not any different, except because it opens out down, A is going to be negative, okay. And our goal today is to finish example 1. And it says here, use the back if we run out of space. I'm definitely going to run out of space because I write really large. So if you don't have the back, then just use a piece of line paper. Okay, so right now go find a line paper or computer paper and, you know, see if you can fit on there and just attach it to the end, okay, or not to the end, behind this. So example 1, the marketing department at Widgets Inc. found that when certain widgets are sold at a price P dollars per unit, the number X of widgets sold is given by the demand equation. X equals 1500 minus 30p. Okay, let me zoom in a little bit. So this is their demand equation. Okay. Part A. Find a model that expresses the revenue R as a function of the price P. You will need to memorize, okay? You will need to have the revenue model memorized. So the revenue model is always X times P, okay? Revenue equals unit sold times the price. That makes sense. How much you make depending on what price you charge and how many you sold. But I want it all in terms of the price. Okay, so all revenue all in terms of P equals, this is not P, so I'm gonna take that out and I'm gonna keep my P here. Well, what does X equal to? X equals to 1500 minus 30p, so that's what I'm gonna put in there. So R of P equals 1500 minus 30p in quantity times P. And from here, I'm going to distribute. So R of P equals 1500 times P is 1500p minus 30p squared. Okay, so this model right here is the revenue model all in terms of price. B. What is the domain of R? Well, if you look at this piece, the domain is what the price is, okay? So a couple of common sense things. Number 1, you're not going to sell an item for negative value, okay? Negative dollar. It's like you're going to pay somebody to take your stuff. That would never happen. Or not never, but most likely would not happen. And also, X is the amount that you're going to sell stuff, right? So you're hoping you're not going to sell negative items either, okay? So the smallest value you're going to sell is 0. So I'm going to take the demand equation. X is how many units sold. So I'm going to take X and let's just hope that the smallest number you're going to sell is 0. And I'm going to solve for P. Okay, because P is what the domain is, the X, what's going to go on your X axis. So if, oops, this is 30p. So what I'm going to do is add 30p to both sides. So this is now 30p equals 1500. Divide both sides by 30. Okay, my P is going to be 15 divided by 30. That's going to be cancel out 0. 15 divided by 30 is 5, so 50. Okay, so the price, which is the domain, I can charge, it's from 0 all the way to 50. You know, some might argue that you don't want to charge 0. You can give it away for free. So I think 0 is okay. I just can't see it being negative. Okay. All right, C, what unit price should be used to maximize the revenue? So what I'm going to do is I'm going to use this revenue equation and put it in my calculator. All right, so here we go. 1500 x minus 30x squared. Okay, my window, we figured out that the price should be between 0 and 50, so 0. Let's make it 100 and zoom fit. Okay, I always want to make it a little bit larger than my domain. All right. I'm not going to get negative revenue, so I'm going to delete a lot of the negative y. Okay, so window, I don't need, oh my goodness, negative 150,000. Let's hope that I'm not going to lose money. All right, so here's my function. Okay, so on part C, let's see if I can squeeze this in here. This is price. You got to label the x-axis and the y-axis in the context of the problem. This is revenue. All right. So if you look at my window, I have it from 0 to 100. And it looks like half y. And y max is about 18,000. Let's make it 20,000. Okay, and you look at the picture, it goes not all the way to the 100, but like that. Okay. So part C said, hey, let's find the max price that we can charge. Why not, right? That's why we're in business. We want to make the most money. Okay. All right, so second trace. This is all I'm doing, second trace. Hit enter. Right bound. Go hit enter. Here we go. Takes a little bit. All right, so I'm going to round that to, obviously if I round it up, it's about 25 bucks, okay? So price, it says what unit price should be used. So price equals $25, okay, to maximize my profit. All right, last piece. D, if this price is charged, okay, so if I'm going to use this price, what is the maximum revenue? Okay, so now I don't have to do any work. Okay, look, my calculator already has it. If I charge $25, my maximum revenue is $18,750. So I'm gonna write it right here. Oh look, I could have just written the answer right there. My maximum revenue is $18,750. Okay, and my price is $25. In part C, our equation was R of P equals 1500 P minus 30 P squared. Okay. Oh, oops. This piece is going to go to part A. And the domain, I'm just kind of putting things together next to the question. So that way it's a little bit more organized. There you go. All right, so let's recap. You are given an equation, a demand equation, x equals 1500 minus 30p. Okay, so the first part was asking you find the model that expresses the revenue, r as a function of the price p. You need to memorize the revenue equation. You need to memorize the revenue equation. All right, so I'm going to take out the x. Because I need to write it all in terms of p. So, but x is going to be equaling out to be 1500 minus 30p. Take that, FOIL that out. This is what you have. Okay. Part B said, hey, what's the domain? How much can I charge? And you can charge between $0 and $50. Okay, by setting 0 in your demand equation and solve for p. Okay, that's the max you can charge. Part C and D will have to use your calculator. Okay, when you use your calculator, you're gonna find the best price, which is 25 bucks. And then in the same screen, it will also show you that you're going to earn $18,750. Okay. Let's see how many examples we can accomplish today. So the first thing is example 2. A farmer has 1,600 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Okay. So when you have fencing, or when you have piece of string, or when you have a wire, all of that is going to help you find the perimeter. Okay, so as you know, 1,600 is the total perimeter, equals 1,600 yards. And perimeter, based on a rectangle, it's adding up all the sides. So I'm going to have 2W's plus 2X. Okay, so 2W plus 2X. So it's kind of like 2 base plus 2 height, or 2 base plus 2 length. Okay. In this case, they're using X and W. So the next, but I'm not really interested in the perimeter. It's asking us what are the dimensions of the rectangle that encloses the most area. So I want to know, hey, what do I need to do to make the largest area for my garden, or for my chicken, or for my pig, whatever it is that I have to use this fence for. So area equals base times height, which is in this case x times w. Well, I have two variables here. As you know, lately it's more difficult to solve an equation with two different variables. To have two different variables, you need two different equations to solve. So for us, we're going to rewrite the area in terms of x, or in terms of w. You pick a variable and you go with it. Okay, so what I'm going to do is I'm going to keep my x, then I'm going to take out the w and substitute the w with something else. Well, the only other equation I have is the perimeter with the w in it. So the first thing I'm going to do is subtract 2w from both sides. So 1600 minus 2, I'm sorry, subtract 2x on both sides, not 2w. I'm trying to solve for AW. So subtract 2x from both sides, so now I have 2w equals 1600 minus 2x. Then I'm going to divide each and every term by 2. So now I have w equals 1600 divided by 2 is 800. 2x divided by 2 is going to be x, so this is what w is. Okay, so substituting this w for that 800 minus x. So 800 minus x. And yes, you can write an equation for a of w. It doesn't really matter which variable you're writing it for. So area in terms of x equals, distribute x times 800, it's 800x. X times minus x is minus x squared. So this equation right here is equation of area of rectangle in terms of x. In terms of x, okay? So from here, you can do it by hand, okay? So let's do it by hand first. I want the largest area. That means I'm going to have to find the vertex, okay? So because this is a parabola, as you can see, this is an x square. It opens down because if I were to rewrite it in standard form, this is minus x squared plus 800x. So parabola opening down. So there's a max point which is called vertex. And to find the vertex by hand, okay? X equals negative b over 2a. Okay. So if I were to write it again in order, it would be a of x equals negative x plus 800 x. So your b would be 800, and negative of that is going to be negative 800. All over 2 times. The first term, which is your a, is negative 1. So this is going to give me negative 800 over negative 2, which is a positive 400. Okay. So let's talk about what x is and what y is. Okay, so let's draw a little sketch. You're gonna have to label your x-axis, and x-axis is your x, which is your base. Okay. This is an a of x equals, so this is your area. Don't give me x and y, okay? This is a word problem that every word problem has a different context, so you have to label it based on the context that we're working with. So this is your base, this is your area. Right now, I know x is at 400. Okay, so let's just say that I'm going to go and put 400 in the middle. Okay, so here's 400x. And we know it's a parabola opening down. So now I know what the base is. Now I just have to find the w piece. So I can do it 2 different ways. Okay, so right now I know my base is already 400 because that's what x is. X is my base. So what is w then? Well, I can do it 2 ways. I can put x in this right here and find out what w is. So here we go. Find my base times height, so height 1600 equals 2w plus 2 times 400. 2 times 400 is 800, so I'm going to subtract 800 from both sides. So that's going to be 800 here equals 2w, and divide both sides by 2. W is going to be 400. Okay, so looks like the dimensions. Okay, the dimensions of this rectangle, it's 400 by 400. Okay, and a square is also a rectangle, so we have to now write the answer. Dimensions are 400. You need to give me the unit of measurement, so yards by 400 yards. So this is my final answer right here. Okay. Now, on the homework or on the test, I can also ask you, hey, what's the largest area I can make? Okay. So the largest area, it's obvious taking the base times the height, okay? Or once we have gotten an x value here in the vertex, to find the y value, which is the area, I can just put it back in here. So let's try it out, okay? 400 times 800. Okay, so all you do is take the 4 times the 8. That's 32. And then you have a total of 4 zeros. So the largest area is when you're going to put in 400. Okay, oops, that's really tiny. Let's zoom in really quick. Okay, so when you put in 400 for the area formula, so that's going to be 32 with 4 zeros. That's kind of how you multiply it out quickly. Then 400 square. 4 times 4 is 16, right? And then 400 also has 2 square in it. I mean, 4 zeros in it. Okay, so minus 16. 1, 2, 3, 4. So you have 320,000. Take away 160,000. The max area is going to be 160,000 yards square. Okay, so this is finding the vertex. But if you have the dimensions, you can take them and multiply as well. So 400 times 400, it's also 1600. So the max area, I'm kind of out of space here. Okay, so what I'm going to do is loop this around above here. Max area is 160,000 yards square. Okay, it did not ask for it in this example, but I might ask for it during the test, or it's definitely going to be on your homework.
Example 3. A farmer collected the data, table on the right, which shows crop yield, which is Y, for various amounts of fertilizer that's used, which is X. In this case, students, it's already telling us which one is the independent and which one is the dependent, okay? So it says here crop yield is Y, so that's dependent, and amount of fertilizer, which is X, that's independent. Normally on an application, it doesn't really tell you which one is X and which one's Y. So make sure you understand, okay, well, dependent, okay, dependent means Y, okay? And independent means X. So when you're reading a question and it doesn't assign X and Y, then you have to figure it out yourself. Part A. Use your graphing calculator or decimals to draw a scatter diagram. Sketch it and comment on the type of relation that may exist between the two variables. So you guys have the plot. This is neither X or Y, okay? That's just extra information that we don't really need to solve a question here. I'm going to use decimals. You can also use your graphing calculator and enter in your data. So here I'm going to flip my computer and pull up decimals. Okay. So let's enter in the data. I'm going to pull the screen over a little bit so I can see the data. Okay, so what I want you to do is hit plus sign, go to the table, enter in your X, which is in this particular question is the amount of fertilizer. Okay, so 0, 0, and so on and so on, and 5 and 5. And then once you're done with the X's, go on to the Y, 4, 6, 10, and keep on doing that. Since I don't want to be wasting your time, I've already entered this in. So next task is I'm going to have it all enter in for us, okay? Okay, so here's all of the data. Now what I want you to do next is to type in and then it says here, okay, well, here's all the data. Another thing is you want to look at your scaling. Since X is the amount of fertilizer, we technically don't have negative amount of fertilizer. So normally I make it -1, a little bit on the left side of 0 so you can see the whole thing. In this case, I'm using -10 to 100. Now, Y is the amount of crops yield, also not negative. So in this particular case, as you can see, I'm using -1, but if you want to, you can go -10. Now, if you look at the table, the largest bushels yield is 22. So as you can see, I kind of make this 25. Technically, can you go 30? Sure. 50? Why not? It doesn't really matter, right? You want to be a little bit more than what the data gives you so you can see the screen. So now that we have the graph, I want you to write it in. Okay, let's move my screen back here. Whoops. Gotta move my screen back and then fill in the information. All right, there you go. Comment on the type of relation that may exist between the two variables. So by looking at your graph, it looks like a nonlinear, okay? So draw the relation between the amount of fertilizer used and crop yield is non-linear. Okay. Now, if you guys want to, now that we have it, you can even say quadratic, right? Because that's sort of the shape that we can see right here. So we can even go back and put in parentheses, quadratic. All right. Use your graphing calculator or decimal to find the quadratic function of best fit. Okay, so now I'm going to teach you how to use it on your decimal, and which I have to flip my computer again. Make sure you double check all the information is correct. So go down here to the next box in decimals and type in Y, and I want you to find this wavy bar right there, just like that. It should be on the left side of your number 1. Okay, so there's a wavy bar. And as you can see, if I type in the quadratic formula, so not formula, I'm sorry, equation, which is ax to the second, ax squared plus bx plus c. Wow, theirs is not working. No equation is shown. So now you have to be careful to go up here. Can you see up here where it says x sub 1 and y sub 1? You gotta look at your table and make sure you enter in the same exact variable as what is shown on your table, okay? So if you see an x2, then you gotta put in x2. So now that we have the quadratic function and curve, we can write it in. I'm going to move this over and write it in our notes. Give me 1 second. So what I'm going to do for us is I'm going to copy down the A value, the B value, and the C value in our notes, just like this, right? In decimals, we type in the Y and then the wavy bracket, which is approximately. And so now, and all of these are from decimals. None of it has to be done by hand. So now I'm going to write Y equals. Now, when you're writing an equation in your notes or on your homework or your test, you don't write the wavy bracket. You write Y equals, and then just fill in the A, B, C value. So negative 0.0171212 x squared plus B value is 1.07652 x, and C value is 3.89394, okay? And that is a function of best fit. That means when we enter the data, whatever the calculator gives us or decimals gives us is the function of best fit. Part C, use the function found in Part B to determine the optimal amount. Okay, again, optimal means the best of fertilizer to apply. Do not round until the very end. So we're going to go back to our decimals and we want to see what the maximum amount is. Optimal means either the best, means it's a max or min. So in this particular case, as you can see, X represents the what? Amount of fertilizer used, and Y represents crop yields, right, in bushels. So when X is 31.438, okay, Y comes out to be 20.816. So that's what we're going to go back and write. Okay, the optimal amount of fertilizer to apply. So now are you going to use the X value or the Y value? Hopefully you said X, right? And let's look at the X one more time to see. X is 31.438. Now, as you know already, this is the amount in pounds, right? So amount of fertilizer, because our data was giving us in whole numbers. So we're going to stick with whole numbers, so which is about 31, okay? So amount of fertilizer, let's go back to the notes, is about 31 pounds, okay, for 100 feet square. So that's our unit of measurement. Now, part D says use a function found in part B to predict the crop yield when the optimal amount of fertilizer is applied. So that means we're looking for the Y value, right? So let's go back and see the Y value. Excuse me. The Y value when about 31 pounds of fertilizer is used is about 20.816. And again, because the data is giving us whole number, we're going to round that to about 21, okay, bushels. So we're going to go to this one. When the optimal amount, oops, that doesn't look like amount, the amount of fertilizer is applied, about 21 bushels. Is produced or yield, okay? And part E said sketch the quadratic function to best fit on the same graph as A. Since you can ignore part A because I didn't want you to do a bunch of dots, okay? So for this one, all I want you to do when it says sketch, it's just look at your decimals or calculator and do a little sketch. Looks like you're starting at 0 and about 4-ish, 3.8. That's what I want you to do. So 1, 2, 3, 4, so 3.8. And then go back to the decimal and where that is 66-ish. Okay, so approximate that, eyeball that for me. And over here, you can write about 66 and go like that. And label your x-axis. So x-axis would be fertilizer. And y-axis would be bushels. Okay, yield. All right.